Assalamu alaikum. I am Tamanna Afroz. Welcome to our project Line Follower Robot of CSE461. As you can see here, the robot is following a line, though we collectively made this whole project, but here I am talking about the part which was done by me specially, which is creating this whole world. Firstly, I created the floor and added 4 walls to it and added bounding object. Then I added a tree, bench and a floor light to make it look more realistic. Then I gave directional light and gave the direction and changed the intensity. Then for making the robot, I gave it a body, 4 wheels, 3 distance sensors which are pointing downwards and a camera. For making the robot's body, I gave box under geometry, under shape, under children of robot. Then for the 4 wheels, I gave hinge joint for the first wheel and gave joint parameters, rotational, motor and end point. And for the other 3 wheels, I copy pasted the first wheel, that is hinge joint, 3 more times and changed the translation and rotation. Then for the distance sensors, I selected box under geometry, under shape, under children of distance sensor and renamed it and gave translation and rotation and selected infrared under type. In same way I made the other 2 distance sensors. Finally I gave bounding object, physics and controller to the robot. Lastly I have created the track which the robot is following from Tinkercad. Let's see how I have created that.
Hello, I'm Mahdi Hassan and my ID is 17101544. I have done the coding part of the following robot here. So firstly, I have import robot from controller. Then I have taken instance of robot controller. After that, I have created a variable for the time step of the current world. Initially, I set the time step to 32. So we will be getting the reading from IR sensor in each 32 millisecond. Then I set the max speed to 6.28. There are total 4 wheels in our project, 2 are in the front and 2 in the back. So I have initialized the 4 motors of the wheels by matching the name with the robot, which are wheels LF, wheels RF, wheel LB and wheel RB. Also I have set the position of the motor to infinity and set the velocity to 0 by calling setVelocity method. There are total 3 IR sensors in our project. These are right, left, mid. So I have connected the IR sensor using the getDevice function, then enable all this sensor by providing the time step. For PID control, we are running a for loop with the following condition: robot.step and providing the time step not equal 1. This simply means it will perform simulation until Webots is stopping the controller. Then we have set the right IR value, mid IR value and left IR value from the output of the sensor's value by calling getValue. Then we are printing the value of 3 IR sensor. After that, we set the 4-wheel speed to max speed. The next part, processing sensor data, will be covered by Humaira.
This is Humaira Taslim Maliha. Before describing PID process of the sensors in our project, let's get an overview of PID. Proportional integral derivative, full form of PID controller, also known as 3-term controller. It is a control loop mechanism employing feedback that is widely used in industrial control systems and a variety of other applications requiring continuously modulated control. The PID controller is widely employed because it is very understandable and effective. One attraction of the PID controller is that all engineers understand conceptually differentiation and integration, so that they can implement the control system even without having a deep understanding of control theory. Now let's talk about the process sensor data of our project. First of all, we need to calibrate the sensors. For calibration, we need some time to check the values of the sensors, that what values are being produced by the sensors when they are in the line or not in the line. If we don't do that properly, it will go out of our track. After calibrating the sensor data, we found that when the middle IR sensor is on the black line, it produces 300 to 400 value. That's why we have given a threshold around 300. So if the IR sensor is not on the line, it gives less than 300 values, and if any of the sensors are on the line, it gives more than 300 values. Here we have given conditions for the sensors. When right and left ear sensor are both touching the floor but the mid ear sensor is touching the black line, then we have followed a straight line by setting the motor speed for front and back to be left speed F and B, the right motor speed for front and back to be right speed F and B. Now if the left is touching the floor but mid and right are touching black line, then we will need to turn to left. So we set the left motor speed to less velocity and right motor velocity to be 0. Similarly, if the right is touching the floor but mid and left are touching the black line, then we will need to turn to right. So we set the right motor speed to less velocity and left motor speed to 0. If the mid ear is also touching the floor, then we have set the conditions for it too, like this.